So what is an ISA? Right. So an ISA is basically a manual consisting of a list of instructions and commands that a software can use to communicate with the underlying hardware. Right. So when you write a program, you only write it using those syntax or those semantics, those keywords that you believe the underlying hardware is going to understand, interpret, and execute. Right. That semantics, that language, that set of instructions is known as an ISA, an instruction set architecture, right? It's like the alphabets of the language or the Hindi language or Chinese one, right? It helps you sentences and it helps you interpret ideas and communicate amongst each other. So to elaborate further, I would like you to take you back almost half a century, take you back to the 360 era, right? Now, what engineers were doing at that time. Programs at that point wrote directly into the machine's unique hardware, right? So they had one hardware and they wrote software only for that hardware. Right? That was how chips were made. And what is the obvious problem? A program for one hardware did not run on, because it's so specific. There was no notion of instruction sets. You would have just one way of communicating and you would define your entire software based on that. Now, if your company made a new generation of a processor, which is slightly better in frequency, in area, in power, or maybe new features, you dump that software and you start from scratch. Right? Now, looking back, this just looks dumb, right? Why couldn't they think of it? But you would be surprised that this is exactly how a game console, right? Or the C patch they get for some of the game PCs will not go out of the box, or the PS4 will not go out of the box for Xbox. Each of them needs to be tuned for specific platforms, right? There is no interoperability of these games, right? So don't go judging back your white hair seniors, but this is still evident in our generation as well, right? But hopefully this issue is no longer there. And some of the issues were every time a new hardware was released, software had to start from scratch. Right? Now you had these two teams, but every time you thought of doing a new hardware, you would wait for the entire hardware to get over and then hand over to the software guys. Right? So obviously these were huge cycle times for building anything. And there was no binary compatibility across hardware. You build one processor and AIM built a processor and Alpha built a processor. You can't run the same software on all of them. You will have to rewrite your software for each of those platforms, and that's called binary compatibility. Because the output of a G compile output becomes an executable or a binary, right? So there's no binary compatibility across hardware generations. And this obviously made software development an expensive domain, right? Now, this is very shocking in today's world where software is costly, right? So unless it's with an AI, GPT, nothing is expensive software. But back then, software was the most expensive part of building. So someone sat down and said, something has changed, and we tried problem. This problem was that we need to expose more common functionality. Right? So there are multiple hardwares from multiple vendors, or within the same vendor, there are multiple generations. There's a lot of things, right? There's ALU, which is always there is add common. Why these differently? Can't we all just adopt the same way of, or at least adopt minimal alphabets that are common? Right? So we have to do minimal change. And that's when IBM came up with IBM 360. That was the stepping stone into ISA, right? They did something called an instruction set, and they said to the programmer and the software guys, forget about the existence of hardware, right? Make sure you write your operating system, your kernels, your application, assuming that this is the instruction set given to you, that you can use only these opcodes, only these instructions to build your software. Whenever the hardware comes, it will somehow be able to execute, right? And it told the hardware guys, forget about supporting the software. As long as you support these instructions in hardware the best way you can, software will work, right? And that's when you found separate teams for you could start simultaneously. Right? the program infos was now independent of the underlying hardware. So a software vendor like Microsoft would come and tell IBM that I can port Windows on yours, and the Unix can say I can port it on Alpha, I can port it, and that's a completely different company. It doesn't even need to know what the underlying hardware microarchitectures are. So binary compatibility across generations. Now companies can share ISA, right? I just have to share a PDF between a software guy, and that's enough, right? Both these companies can make money out of the consumers without having to know each other's trade secrets, right? So you don't have one company giving you an entire solution. You can go and aggregate hardware from somewhere, software from somewhere, and so on. So as you see, instruction set is the most crucial aspect between software, right? So everything on top is operating system, virtualization, virtual machines, and blah blah blah, all of that happening. And below, you're going to start with processors, SoCs, IO systems, digital design circuits, transistors, current, blah blah, MOS, everything like that. Right? In the middle, where the actual transaction happens from one domain to the other, is the instruction set. Right? So it forms the most important part of today's stack. When I say stack, I'm not software or hardware. I'm talking about the entire stack, from transistor to Firefox-based applications or whatever, right? OpenAI, something like that. So what does an ISA include, right? We keep saying instruction. So it talks about multiple things. One is what are data types supported by hardware. Right? For example, does it support integer operations? What is the size of the integer? Is it 32-bit, 64-bit, 16-bit, 8-bit? Does it support floating point? What are the types of registers available? How much memory does it support? What is the RAM size that it has accessible to, right? Then it actually talks about the instructions, right? There's an add instruction, there's a subtract instruction, multiply instruction, and all of that.